So I'm already back. As you can see, we are still in the same room and we are still testing the RTX 2080 Ti. In the previous video, we took down the dual card SLI times by extreme record, and today we will try a single card. We also did a lot further and deeper into investigations for the power target problem, because even on SLI we still had the problem that the cards would run into the power limit. Even we tried special BIOSes, we tried all kind of typical modifications which we have been doing recently. So of course the liquid metal can be done across the shunt resistor, then we can bridge the shunt resistors, but even then we still have the problem. If we bridge it, if we bridge two of those resistors, it will go in the 300 megahertz state, so the card would not detect that it's actually in 3D. It will always stay in the 2D mode, and the clocks would always stay at 300 megahertz. If we only bridge one 8-pin shunt resistor, then we have the problem that the card will have something like 105-110% power target detected in GPU-Z. And we noticed that whenever the card goes to 100 or above, there are some points in the benchmark where the clock is already dropping down. So for example, we set 2400 megahertz in the times by extreme. It stays stable in the full GT1, but in the GT2 at the beginning the load is so high that the card would clock down to like 2200 megahertz and we lose a lot of performance. So we thought, okay, we have to improve the power target even further. And if you've also recently been following Bullzoid made a video where he investigated the power target further, and where he said there is a different solution or an easier solution to trick the power target. So the theory of a shunt resistor is that you have the voltage input from 12 volts, so the PCI Express connector here, and then the full power is going across this shunt resistor, and the shunt resistor is a fixed value, typically 5 milliohm, and there's an IC on this card, it's on the bottom here, and this IC knows that the shunt resistor has a 5 milliohm size, and it can measure the voltage drop across the resistor. And just by easy math calculating the resistance and the voltage drop across the resistor, you can easily calculate the current that is flowing across the resistor itself. And typically what we do is we just give it more room where the current can flow. It can flow kind of outside the resistor, so it's fooling the voltage drop and therefore fooling the measurement. That's what we typically do for the power consumption modding. So what we tried was bridging the resistor. We tried to replace the resistor, and we always have the problem that it's either too much, so the card would go into the 300 megahertz error state. So for example, if we bridge two resistors, or if we exchange it with a much lower value, so 2.5 milliohm for example, then it would always not detect that the card is actually running in 3D, and it would always stay in 2D mode. Now Bullzoid came up with the idea to fool the actual voltage drop across the resistor, so you have to solder some additional resistors in between and therefore simulate a different voltage drop across the resistor, or you could actually also feed fixed voltage directly to the IC and therefore give the IC permanently a static value, so it would always detect the same power consumption. But it's not really easier. It's a lot to do. You have to get the components, and it's also a lot more soldering to do. So we came up with a different solution, something we actually used before on this card. It's a Titan X. Oh yeah, it's a Titan XP, so Pascal. And we also had the same problems on this card. This card was not as tricky to get to work, so we did not run into this error state this early, but we also had the problem on liquid nitrogen that we would always hit the power target, and we always had to do some kind of modifications. We bridged the shunt resistors completely, even with very thick wires, as you can see here, the wires across the shunt resistors, and this worked. It didn't go into the error state or the 300 megahertz state. So on this card it worked fine. But we needed even more than this, so we decided to solder an additional voltage source to this card after the point of measurement. So we just added another 8-pin connector, or 6-pin connector would also work, to points of the 12 volt and also to ground after the voltage measurement. And that's exactly what we did on the RTX 2080 Ti as well. So we have two additional ground points that go to the right here, and then we have 3 points. Actually, 2 of the points are just after the shunt resistor, and 1 point was an additional empty pad where, yeah, I think it's a pad where they could have placed a capacitor, but it's an empty soldering pad, so we just added the power connector there. So some of the current can just flow to the card without being detected at all. And we tried this with a single card quickly, and it worked out quite nicely. So we still had sometimes the problem that the card would go into the 300 megahertz error state, but then the thing is, if we add additional voltage with the Elmore EVC, let's say 1.25 volt GPU voltage, then the clock would ramp up and it would always stay stable. And what is even more important is that the power target would always stay at around 80, 85, maybe 90%, because we detected that whenever the card hits, let's say 100, 102, 103% in the GT2 of the benchmark, so the second graphics test, it would already lose clocks. So if we would clock this card to 2400 megahertz, would stay stable through the GT1, but in GT2 at the beginning, I don't know if the load is just so high or whatever is causing this, but the power consumption hits 105 degree or 105%, something in this direction, and then it would already lose clocks like 50 megahertz or 100 megahertz, and therefore obviously we lose performance. That's what we don't want. That's why we did this solution. It's something I would not recommend to do at home for a daily rig, obviously, because we don't even know how much current is flowing there, and also additional voltage like 1.25 is something you should only use with extreme cold, because we also tested it with like air or water cooling. You cannot expect any benefits from additional voltage. You need extreme cold for the voltage scaling, which we have because we use liquid nitrogen. We can go to minus 100, maybe even minus 150, and therefore we can have use of the additional voltage. That's what we will do now. So we will mount this card with the liquid nitrogen container in the system, and then we will see if we can break the single card record. So quick update, we've been testing the card for about 1 hour now. We had some trouble in the beginning, but now everything seems to run quite smoothly. We managed to overclock the card so far to 2430 megahertz on the core, and we almost passed a run at 17,000 megahertz on the memory. And now we're trying to increase the memory voltage as well, apart from only the GPU voltage. We tried the GPU voltage in combination with high GPU frequency, and we noticed that we cannot really run 1.25 volt on the GPU, because in combination with the high GPU frequency, the GPU will still throttle. So we are limited to about 1.175 volt from what we can test now, which seems to be fine for, I don't know, something, maybe we get close to 2500 megahertz on the GPU with a bit more tweaking, maybe a little bit colder temperatures. So let's see if we can get the memory to run even higher, maybe 17,000 megahertz will be stable. And the target is 52.5 FPS roughly in the Times by Extreme GT2, so in the second graphics test. And so far we managed to get 50 FPS, so we're quite close. Let's see if we can get it. Okay, 2 days later, so we originally started Sunday evening with this, and we thought it would be very quick as usual. You think, okay, the score is not that far away, we can just push a little bit further and we will get it. So on Sunday evening, the highest score we could achieve was 9,228 points, which was very close to the current record of Kingpin. And we thought, hey, just push the card a little bit more and we will eventually get the record. But then we had some trouble. I think we just had some condensation water underneath the GPU or underneath the memory, because we experienced some artifacts on the GPU, and even after drying up the card, we still had those artifacts. So we were not sure if there is some kind of problem, maybe a BGA failure. So some of the solder joints would crack between the PCB and the GPU or the memory, or if it was just some condensation water. So we heated up the card, tried it again, it was still there. So we thought it was broken. So we tested all other cards we had, and all of them were a little bit worse. So one card was a little bit better on the memory, but then they were a lot worse on the GPU speed. So we tried all of them, and then eventually we decided to try the first card again. And it worked again. So the additional power connector really helped, but even then we still had to modify also the shunt resistor of the PCI Express slot, which we didn't want to do in the first place because we wanted to stay within specs. But we saw that even with the additional power connector, we still had throttling at some sequences of the benchmark. So we did that in addition, and then we had even clocks through the whole benchmark. And then we started to push the GPU even more. We went with 1.25 volt on the GPU. We had almost 2,500 megahertz on GPU clock in times by extreme. Also almost 17,000 megahertz on the memory. So that was a very good combination of high memory frequency and also very high GPU speed. And we did it. So in the end, we broke the single card record, which was 9,312 points before. And we set the bar higher to 9,367 points. So Kingpin said in a live stream that it's lonely at the top because nobody is competing. Kingpin, now we can be lonely together. I'm actually curious what kind of backups he has, because typically I know Kingpin, he always has some scores that are a lot better than what he already put up online. So we will see what happens. But so far, for now, we are the new world record. So thanks for tuning in. See you soon.
Don't include that in the video. Don't include that in the video.
What did you do? Did you fail?
No.
Yeah.
Nothing happened.
No worries, I always cut out the parts where we fail.